Oil spills are one of the most severe forms of environmental pollution. Spilled oil can spread widely across water surfaces, damaging ecosystems, endangering marine life, and even affecting human health.
This problem often arises from leaks during transportation, drilling, or industrial activities. Conventional methods to handle oil spills, such as using synthetic sorbents made of polypropylene, are effective, but there's a major downside.
These synthetic sorbents are not biodegradable, creating a new issue of plastic waste that further pollutes the environment. Therefore, an environmentally friendly alternative is needed, so that it can replace these synthetic sorbents.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon everyone. My name is Naura Shafira and alongside my partner is
Zinnia Mysha.
We are from PRIBADI Bandung School.
Today, we are going to present our research with the title, Oil Spill Remediation with Modified Natural Polysaccharide guar gum, Assessment of the Potential of guar gum as an Active Ingredient of Oil-Absorbent Fabrics.
Through this research, we have several objectives. First, measuring the oil absorption ability of modified guar gum to determine the maximum oil absorption capacity. Second, evaluate the effectiveness of modified guar gum as an active ingredient in environmentally friendly oil-absorbent fabrics, especially under various conditions of use. Third, analyze the potential use of modified guar gum as a sustainable alternative for oil spill remediation and compare its effectiveness with conventional synthetic sorbents.
First of all, we'll be making the unmodified guar.
To start making the unmodified guar gum solution, we will require a beaker filled with 0.36 grams of guar gum and 100 ml of water and stir.
The modified version will need another beaker with the same amount of guar gum and water, creating a homogeneous solution. Use a balance to measure 0.3 grams of boric acid and 0.2 grams of sodium chloride. Then put it into the beaker. Add sodium hydroxide until the pH of the solution reaches 12.
Secondly, for the oil absorption capacity test, pour 2 ml of oil into both beakers filled with unmodified and modified guar gum solution. The absorption process of modified guar gum in oil will take 40 minutes. Weigh the guar gum after absorption and calculate the amount of oil absorbed to find the absorption capacity using the following formula.
From the test result of the ability of guar gum solution to agglomerate oil within the beaker, we can see that the modified guar gum has a thicker structure with higher oil absorption. It is shown that the oil in the solution is completely absorbed within 48 hours by forming clumps of guar gum and oil that stagnate on the surface of the solution.
Unmodified guar gum has a thinner structure with low oil absorption ability, characterized by the oil still mixing with the solution and not turning into clots after 48 hours.
In the following table, the absorption capacity of modified guar gum is 1.5 grams more than the absorption capacity of unmodified guar gum.
Thirdly, in the oil absorption capacity using fabric unmodified guar gum test,
Guar gum is dissolved in a small amount of water and applied to fabric by soaking for 10 until 15 minutes for even distribution. The fabric is then dried in an oven at 150 degrees Celsius for 10 minutes. After that, weigh the fabric before and after absorbing the oil.
as seen in the table, the results obtained show that the modified guar gum fabric absorbs on average 0.02 grams more oil than the fabric without guar gum. Fourthly, we will analyze the results obtained for Fourier transform infrared spectroscopy, in other words, FTIR, of modified gorgam. Modifications to gorgam successfully enhanced its hydrophobic properties, indicated by the decrease in hydroxyl group intensity and the formation of new groups like borate esters. This supports the potential use of modified gorgam as an oil-absorbing material.
Finally, hydrophobicity analysis results. Hydrophobicity analysis to test modified gorgam includes measurement of contact angles with water and oil. The water contact angle before modification was lower, but after modification, it increased. The oil contact angle was lower after modification, indicating a higher affinity to oil, signaling the success of the modification.
This research modified gorgam from hydrophilic to hydrophobic. The changes were confirmed by the FTIR analysis, contact angle measurements, and oil absorption test. FTIR showed that after modification, the hydroxyl absorption band decreased, indicating fewer hydroxyl groups. Contact angle measurements reflected these changes. The water contact angle increased and the oil contact angle decreased after modification. The oil absorption test indicated that modified gorgam absorbed more oil compared to the control, confirming its hydrophobic properties and its potential for oil-absorbing applications.
Last but not least, we can conclude that modified gorgam improved higher oil absorption capacity than unmodified gorgam in the FTIR test. The modified gorgam sorption fabric is environmentally friendly and can absorb more oil, proving the potential as an alternative to synthesized sorbent.
And this is the end of our presentation.
We hope that the research you have done can help preserve marine ecosystems and the environment. Thank you for your attention. That's all from us.
Wassalamualaikum warahmatullahi wabarakatuh.